My name is Grimm. Only a few words about me. I'm a software developer, software consultant since the last millennium. Since 22, 24, I give classes, do a lot of further education in companies. Since 24, I give Python classes. Since 26, C++ classes. Since 28, online classes. This was, by the way, terrible at that point in time. And since 2016, I only do what I love, teaching. Mainly C++, but also a little bit of Python. Okay, today I want to talk about a really interesting thing about C++ 20, the current C++ standard. But I have to say something. I will not talk about the big four. Ignore them. I only talk about, I call it the small pearls, but honestly, even these small pearls are way too big to present in 1 hour. My original idea was to reuse a talk I gave at ACCU 1 year ago. This was about 90 minutes. Then this morning I thought, oh, okay, I just remove 30 minutes. And then I recognized Windows, the example will not run on Windows anymore. On the compiler explorer, what I mentioned today during Matt's talk. Therefore, now I restructured it to GCC. Okay, let's start. Let me say, before I start, additional remark. Features such as the calendar and let me concentrate on this one. The calendar and time zone extension by Howard Hinnard is so big. I think it required me and Nico 80 pages in a book to describe what's inside. You see, that I can only give you a gut feeling. I show you for example, but I will not go into the details because it's way too much. And you should also know what's in the Chrono library in C++ 11 because it's extension. You see, there's a lot of stuff inside. Let's start with the core language. We have now the three-way comparison operator. I see if I should do it this way. Yeah, I do it this way. This is also called spaceship operator. And you know why? Where is it? Here we are, because of that. By the way, never automatically translate that stuff. In German, it's called the Raumschiff operator. Anyway, spaceship operator. You can implement it by yourself, or you can ask the compiler for it by saying equal default. Equal default means, first of all, you need the header compare. It's implicitly const expr and no except. And it compares lexicographically. Lexicographically is pretty simple. When you have a phone book, the names are sorted from left to right. So first you compare the first character, and the second, this is lexicographically. And you stop when the decision is made. It's also lazy. Okay, this is done lexicographically. In this case, it means when you ask for it equal default, all base classes are regarded from left to right, and all non-static members in their declaration order. And the compiler just forwards this equal spaceship operator to all the members it has, and all the base classes. It's just a delegation mechanism, such as always in C++. When you delegate the move constructor, it's just a delegation mechanism. And there's a shortcut for equal or not equal. When you compare two strings, and they are so long, and only the last character is different, it would be a bad idea to do it lexicographically. So what you do first, you compare the lengths. And if this length is different, you say they cannot be equal. This is a shortcut out of performance reasons. Okay, here are two simple examples. Here I implemented it by myself, you see, by relying on the spaceship operator. And what I get here is a strong ordering. So you get a kind of an ordering. Why do I get a strong ordering? Because I have what? An int. All ints are comparable, therefore I get a strong ordering. This is the return type. Please use your auto. If not, it's a little bit complicated. When I do it this way, and I have a double inside, I only get a partial ordering. Why? because there are floats which are not comparable, such as none. And this is what you automatically get, the most powerful ordering. In this case, use always auto. At least I would say it this way. By the way, this is a nice idea. I often have discussion in classes, should we use auto or not? Here, I strongly suggest to use this. Okay, so there's a little bit special about the three-way comparison operator. When the compiler sees that, the compiler makes that to that, you see? And there's also something very, very interesting. It's symmetrical. When A smaller b does not work, it rewrites this expression to 0 smaller b compared with A. So it's symmetrical. If smaller b does not work, b bigger than A is applied. I almost made an error. Okay. When you already have an operator of the big 6 defined in your class, and then you also ask for this default operator, your user-defined operators have higher priority. You can in some way also mix them. I don't know if this is a good idea. Anyway, but you can do it. I will not show this example because essentially I should not say it, it's trivial. I hate this word. My math prof always said, this example is trivial, this proof is trivial. I could not understand it. He always said, I hate this expression. Then we have designated initializers. This is a feature which is based on aggregates. What's an aggregate? Could be an array, a class type with the property that all members are public, no user-defined constructor, or no virtual members or base classes. And now we can have aggregate initialization, which means you can directly initialize this thing using curly braces. Looks a little bit like it initializes, but it's essentially something else, but it works a similar way. And now, based on that, we can do something which you may know from Python. It's not so nice, such as in Python, but we know it. You can use the arguments by using the name, you see, x and y. Therefore, you initialize here x and y, and here you use the name of these members. The values here can also have default values, and anyway, you specify them not in the way of either the value you specified or the default value. So, now narrowing conversion will happen here, meaning when you want to have fun and you want to initialize this int with a double, you will get a compile time error. I have to be sure, I have to be exact. Essentially what you get is a warning, and then it depends on your compiler, so if it's a compile time error or not. But you get a warning, or as the standard says, is diagnose required. Okay, but now I show you something. It's maybe, this was wrong. Here we are. No, here we are. Okay, this means when you get my slides, the examples are included. I hope this is big enough for you. I cannot make it bigger. Okay, who was it? Fine, because I always ask the people in the last row, not in the first row, because always the people in the first row say, it's big enough, I don't care. Okay, you see this is a point. X, y, and z are initialized, so x not. Here I have a function which takes a point. And now I can do it this way, x, y, z. I can do it this way, x, y, z. And by the way, here I invoke the default constructor, kind of. And you see there, no, don't see it, x has no value, you see. Therefore, this is, how should I say it, undefined behavior. The standard says, by the way, in this way, in this regard, x has is initialized to an arbitrary value. You can also say in this way. We don't know what's inside. Then we have x and z, which is fine because y has a default value. But what you cannot do is to switch the order, z and y. And this is also, I don't know if you like it or not, but it looks nice. You can also use here a kind of an initialize list, or I should say aggregate. And here you only specify x and y and z have values. Therefore, we see this output here. Once more, if you want to spare keystrokes, this is maybe your syntax. Similar to initialize lists. You essentially only provide the arguments for the constructor, but not the data type. Okay, let's jump back. Yeah, do you have a question?
Yes. Can you explain why the one error case that you have, there is an error?
Okay, maybe I was. I have it.
I mean, I know the answer, but...
When you know the answer, why do you ask anyway?
Because people on YouTube later might not know.
Okay. The question is that here the order is x, y, z. And here I initialize it in a different order. Please control me. Also for the rest of the talk. Be sure that I don't make an error or forget something. Okay, let's jump back. Constable. You know, I gave at cppcon, I think in 2020, and 1 hour talk only explaining what different kind of constants we have in C++. And now this is Constable. You know a usual function. It can only run at compile time. You know a contextual function. It can run at compile time or at runtime, depending in which context you use it. And now we have a third guy, is Constable. This can only run at compile time. We call it also an immediate function. And Constable cannot be applied to destructors or functions which allocate, deallocate. The requirements for Constable are essentially the same, such as for constextual, because a contextual function has also the potential to run at compile time. And here's an example, and you see I fixed it. Here's consteval. This works. This works out, but this works not. Because here you want to have the value at runtime, and SQR can only run at compile time. This is consteval. Okay. And now I could talk about pure functions, mathematical function. Of course, this is one. So it's extremely, how should I say it? The result of the function only depends on its arguments. Let me put it this way. Okay. Then we have constinit. Constinit is also a new keyword in C++ 20. And this guarantees that a variable with static storage duration is initialized at compile time. What does static storage duration mean? Global objects, so objects outside any scope, or objects declared as static or extern, have static storage duration. They are initialized essentially during program startup and the other way also destructed when. And we have a nice feature in C++, which is called static initialization order fiasco. Who knows this feature? Nice, or? And constinit is a nice way to get rid of it. Static initialization order fiasco essentially means you have two statics and two translation units. The initialization of one depends on the other. And now you have a 50-50 chance that your program is right or wrong. And the same holds, by the way, for destruction. And only a short example. This is static initialization order fiasco. This is one source file. I have a static A, you see. This is another source file in which I use this static A. And they both depend on each other, you see. And now depending, this is not a proof that this is called no proof, but I only want to show you. When I now link this program in a different sequence, first main, then source, here source, and then main, I get once the value 0 and once the value 25, only that you see it. Because static variables are initialized in two steps. During startup, 0 initialized. During runtime, the value. And now you see what's happening. And how can we solve this issue? Of course, make them constinit. Sorry, constinit is missing. I should have added. Sorry, I removed this slide. So just add constinit to it, and then you have the guarantee. Okay. Templates now can have floating point numbers and classes with context per constructor. Okay, you know it. But here's something interesting, which often people irritates. We have now template lambdas. Have a look here. Template lambdas. Why? What we have essentially is now typed templates, 11. Generic templates, typed lambdas, now I have it. Generic lambdas, 14, and template lambdas, 20. Let me show you an example. There's really a use case for it. Here you see it. This is a 11 lambda, only accepting int. This is a 14 lambda accepting arbitrary types. And this is a template lambda, meaning first and second must have the same type. I assume this example is not promising to you, but this one is. Look carefully. I want to accept a vector, but I don't care which kind of elements my vector has. So I have a vector of t. So I can invoke it with a vector of int, double, and a vector of a vector. I think this is sometimes something you want to have. Oh, of course, you can also here apply concepts and stuff like that. You can do ranges and concepts. And there's a lot to it. But anyway, you can do it. Okay. I have to admit this was a small feature. And now we skip to library. 70 minutes, 80 minutes, not so bad. We have stood span. Stands for an object that refers to a continuous sequence of objects. A span is never owner. Honestly, I don't know it. I would call it a view, but anyway, it's essentially a view. I don't know why we have different names for the same ideas. So it's a, oh, I'm recorded. I should shut my mouth. It's never an owner. Its reference area can be an array, a pointer with a length, or a std vector. By the way, you could also use a std string, but this makes no. Yeah, it makes a little bit of sense because in 70 you have a string view, which is pretty similar. You see, now it's called a view, not a span. So I don't know it. Okay. So the typical implementation has a pointer to the first element in its length. This is all what you need. It also allows partial access to a contiguous sequence of elements. You can also modify them. My favorite example of a span is, you know what is a lot of fun in C? When you have a function which should accept a C-array. What is the signature of a function accepting a C-array? You know it. This is the fun part. A pointer, of course, and maybe a length. Okay, but let me stay with pointers to continue my story. And you know what? This is a decay. A type-rich structure, 15 ins, is reduced to a pointer to its first element. When you have a bad day, you have a bad program because you miscounted. And with std span, this can easily be fixed. You just accept a span. And a span can, you have a look, I have here a function taking a std span of int, you see. It displays its size in its elements. And now I can invoke it with a C array, with a std vector, and a std array. And it deduces the size of the C array. And therefore, you cannot miscount because it's not your job anymore. It's an extremely simple example, but I think this fixes many issues. But you can do more with a span. You can even modify it. Let me do something different. and show you immediately the program. Okay, this is a bit more complicated. Not really complicated. Okay, what do we have here? The same function as before. This is boring. We have a vector. I display it, you see, 1 up to 10. Now I make out of this vector in span. I initialize the span with a vector. This is the right way to say it. Then I create a subspan, starting with the first element and ignoring the last element, you see? And now I transform this span here, span 2. I iterate from begin until end. I write the result to begin, so I overwrite myself. And I overwrite myself by saying E should go to E times E. This is my lambda. And now you see this is the result. And this addresses also vector, which I originally started, and my span 1. So you can modify the underlying elements. And now in case I started with 1 to 10, and now I have 2 to the power of 2 up to 9 to the power of 2. And now I lost my mic. This is too heavy for me.
Any particular reason why on line 22 you're using parent and on line 23 you're using curly to initialize?
Let me put it differently. When I would give a class to you, I would say always use curly braces. Right. I have to learn it the hard way. You should use curly braces for initialization point. Okay. You are really extremely picky, but this is right. No, sorry. I have to be sorry. Container improvements. Now to something which was for me magical. With 20, std string and std vector are entire const expr. Each member function is const expr. And you know what? Both allocate memory. This is a little bit crazy for me. It goes further. All algorithms of the standard template library are const expr since 20. Have a look what you can do in 20. I have a function which is declared const expr, you see? I create a vector here. I sort this vector and return the last element, which is the biggest one. And by the way, here I take this argument and display it. And I can also do it with a lambda, just for fun. I have here a lambda, which is so-called immediately invoked. And this gives me back the biggest value of these 4 values. For me, this is mind-blowing, honestly. This is C++ 20. By the way, I should add with 23, unique putter is also const expr. This goes back to Andreas Fertig. Okay. I should not talk about 23, but I will also mention once more 23. Okay, continue. There was something which was often made wrong, and this was the so-called erase remove idiom. People erased something and they thought it was removed, but they only got back the logical end of the new thing. And now we have with C++ 20 the function erase and erase if. Erase if can also be used with a predicate. And here I use as a predicate a lambda, you see. Erase all of the string which is upper. And now you see I made out of a nice string an ugly string. And this is erase or erase if. Erase, of course, only in character or the element you want to erase. Erase if, you can provide a predicate. A function returning true or false. Okay. A few smaller features. By the way, you should never use signed and unsigned in an arithmetic expression. And for that reason, we have special functions. Compile equal, compile not equal, and you know what this means. Why? They deal with the fact. Here you can use signed and unsigned in a comparison. You may say, why? I see no issue here. Believe me, there is an issue here. Have a look here. Okay, what did you learn in school? -3 smaller than 7? Yes, but this returns false. But here it returns the right result. You see? What is happening here? We can make a long story out of it, but just use CP insights. And now you see what's happening. Now I have to hit the button. You see, the int is casted into an unsigned int, and now it becomes really, really big. Okay. So use it. Then we have a few mathematical constants, which you may know. It's not so interesting. Sorry, I will not go into this direction. There's way too much in C++. 20. And now to the not more interesting stuff, to additional stuff. Calendar and time zone. Once more, this is an extremely big addition in C++, 20. Goes back to Howard Hinard, and I hope he will give in some point in the future a 1 day's talk at least, what he all added. With 20, we have additional libraries. We have the notion of a time of day thing. We have time zone support and a nice syntax to use this stuff. I will not explain you the theory. I will show you 3 nice examples. So we have an idea of a calendar and a nice syntax to create calendar dates. We have the concept of time zones. And by the way, when you use time zones on Compiler Explorer, I used it often, in particular on Windows. When you use that, there's a database connection request going on under the hood. And then you get on Compiler Explorer a timeout. It will not work. I already discussed this issue with Matt. But with GCC it works. You will see it in a few 5 seconds, but not with Microsoft. Okay, let's start. Time of day. This is the time of day. The second since midnight. Here I create this data type. Originally it was really called time of day. Now it has a little bit of a strange name. And here I create it by using time literals, you see? And now I can ask for it. It says this is the time of day. And here I use the first time something, which is the new format library. This is, by the way, what I also changed this morning. Sometimes I show you both syntactic variations. This is the old way, this is the new way. And now you can, let me jump 1 step back. With format, you can display all built-in data types, user-defined types when you implement something, and also all chrono things. And here I use the chrono thing. And this was, when I was in the ACU, not possible so far. Therefore, I changed it. Okay, then I can display hours since midnight, minutes, seconds, sub-seconds, and duration in seconds. This was the wrong one. Durations in seconds. And I can also do it in a different way. I can also say I initialize it with the seconds, and what I got back is the time. This is time of day. So this is a new data type, which gives you it's a little bit long, this cable. 10. It's a complicated talk. It's not due to C++. Okay, queued syntax. This is the queued syntax. This term is coined by Howard, who, by the way, was also responsible. Oh, damn, there's the wrong link. Damn, I fixed it. Sorry. Let's jump to a different compiler. GCC 13. Sorry?
Will this feature works in clones too, or not?
I'm not sure, but I know it works in GCC. So I don't want to concentrate here. Why does it work? Because I have to specify a flag. and this is the Windows flag, which is of course here wrong. Now we have it. Wait a second, here we are. You should never do live coding, sorry. Okay, this is my birthday, you see, with chrono year. So this is its own type. And you can specify a calendar date in 3 ways. Starting with the year, with the month, or the day. And by specifying the first argument, the other 2 are fixed. Why is this way? Because Howard said this was heavily used worldwide, so we use that. This is here I start with day, here I start with month. Therefore, I don't have to specify here the type. And this is the cute syntax. I don't know if you like it or not, but this is the cute syntax, you see? It's overloaded. And when you do something crazy, you get a runtime warning. It's not a valid date. There is no 26th month available, at least as far as I know. Okay, let's continue. Yeah.
Before you close this, can you please change GCC to Clang so we see if trunk Clang works as well?
Only once. I will not do it once more because my issue is I have a time issue.
Oh, thank you.
Yeah. And the next issue is I should find my right. Which Clang should I use?
Yeah. Okay. No, that's not. Thank you.
This was a bad idea. Local time. Local time. Sorry, local time. Now fine, here I fixed it to GCC. Local time means I have a time, and sorry, we are now in Britain, therefore we don't see anything here. In Germany, I would have an offset of 1. Sorry. So I created this program in Germany. Do it in your local time. So I have local time, system synchronized now. Then I display it, and here I use std format, you see. And here is what you get. This is the UTC time. And now I do it in my local time, which is, as I'm sorry to say it, the same such as UTC time here. And I do it, here we are. This is what I forgot to mention. I now specify the chrono zone time by asking for the current zone and this UTC time. Now I would get it in Germany 1 hour later, but due to that I'm in England, we get the same. And finally, I can also ask for the offset between UTC time and local time, but this is also here 0.
So it's not aware of summertime?
It's aware of summertime, of course.
But it should be summertime.
We have summertime, yes.
Yeah, I mean, like in UK, that was a +1 for UTC.
I'm not sure what's happening here. So far, it always works the way it should work. I will show you a more complicated example in my next example, and we should talk about this later. But once more, this is an extremely clever library. And when you do such thing as that here, internet connect database will be called. Okay. To the next example, this is a little bit more complicated. You know I have an issue. And the issue is the following. I give worldwide classes, worldwide mentoring. And I have in my mentoring program, which is at Friday, people from Sydney and from Seattle. They are a count of 80 hours apart regarding time zone. Maybe it's 90, I don't know it exactly. But and therefore I always search for the right time. And here's my small example. Now it's in the past. And here I use winter time. So this was my challenge. When I give a class at this date, 2021, 1st of February, and I start at 7 o'clock, 1 o'clock p.m., 5 o'clock p.m. And my class takes 5 hours. How late is it in this specific time zones? Because I search the right time spot. And this is what I did. I say, go through these time points. No, this is not a time point, it's time duration. But anyway, and then print start end time. I will not show you all of the stuff, only give you an idea. Here I got the local day, the start point of my class, its duration, and here, oh, I made a mistake. The first argument is the local day, start time, duration, and here I got the time zone. This is what I get. And now, first of all, I calculated on my current zone. Now, my current zone is, of course, England. The start point of my class. So local day plus hours. And here, the end date is local day plus hours plus duration for hours. And I display it here. And this is the start point of my class. You see? 7 o'clock, and it ends at 11 o'clock at this specific date. And here it's winter time because, at least in Germany, we have winter time. I assume this is also the same in Britain, but for me it's winter time. And then I did it way more interesting stuff. I iterated through each time zones you see here, and I display this time with a zone time, meaning respecting the time zone. And here are all the times. And now you see it's pretty complicated when you give worldwide classes. So when I start here, this is the time in these different areas. Los Angeles, Denver, and so on and so on. And you see, even when I start at 5 o'clock and end at 9 o'clock, in Novosibirsk, it's even the next day. This was just a challenge for me, and you see this is pretty nice. There's a little bit of formatting done under the hood to lay out in a nice way, but this is extremely nice. And once more, this program always failed on Compiler Explorer because it took too long and I got a timeout. But with GCC it works. And here, only to see is the same expression based on format. And I use, now I have a question for you. Why I do use here format and not format, but V format? Any idea? Format requires a const expert thing. And I have runtime things. And therefore I have to use for format, and I have to also modify my arguments so that they are usable. So essentially, formatting happens by default at compile time, but you can also do it at runtime. But then you have to do it a little bit different. And this is the reason why format is so fast. By the way, this is a nice point, because now I jump to format. We have the formatting library. Once more, I don't talk about theory. Please read my blog post, read my books, read the books from Nico, read other books. This is way too much. Whom of you uses Python? This is essentially Python's format string. A little bit simplified, but it is. Therefore, it's pretty easy. The only thing we cannot use, what I love about Python, is named arguments. This is very nice, but you cannot do it in C++. So you have a format specifier following Python rules. What you can at least do is you can specify the position of arguments. You see, out of world hello, you become hello world. This is pretty nice. And here, this is the format specifier, and this is the syntax you may know from Python. I show you a few simple examples. Yeah. And once more, this must be a compile time thing. And when you want to do it at runtime, you have to use V format. And you have to also modify the arguments. Okay, I don't want to bore you with details. I only want to show you two very nice examples. Not very nice, at least nice. Okay, so you have it all for basic data types. You have it all for chrono data types. You can just throw it in, use empty curly braces, and then they are displayed in a default format. And when you want to specify it, use a format specifier. And you can do crazy stuff. So crazy that I want to do something crazy this morning and I failed. Okay. Further data types. Here's a simple thing. Here's a simple thing. And afterwards, I cheated a little bit. But anyway, this is not cheated. You see here, here they are just displayed as they would be displayed. Hello World 2020. Here I changed the order of the arguments. Here I use the first argument 2 times. And here I use only the first and the second. Maybe, by the way, you can of course have here more arguments than here, but at least they must be enough. And now comes the cheating part. But maybe for you it's right. The cheating part is the following. Originally, when I played with this feature, and it was not supported by all what I needed, I used this prototype library from Victor, you may know, FMT. And I used it and I said, oh, have a look what we can do. And can do in a few days also with C++. I used a vector, such a long vector, I made line breaks and all the stuff. It was beautiful. But it didn't work finally. Then I switched to C++ 20 and I recognized, this does not work. Sorry. But here's something I want to say to you. Please don't blame me. This is a 23 feature. And now I have something for you. It only works with Clang. Here, have a look. Here, now you can directly display in vector. This is the default format. You see? Here, you see something strange. 2 times column. The first column goes to the entire vector. The second column let me say differently. The first column starts the formatting of the vector. The second goes for the elements. And here I say plus, which means each element gets a plus. And here I say, do it in a hex version. Here I say, do it in a binary version. And only just for fun, I use a string. So far, it's boring. But here I say, only the string, the first 3 characters of a string. I don't want to go into the details, but you see, this is what you can do, pretty nice. And I will try in the future to also introduce here pipe symbol to introduce line break, which I achieved with FMT, but so far never tried out this way. And by the way, only for you, this is what you have to do on Clang. But at least it works. This is the only compiler. This is so strange. Clang does not support format, but in the experimental version, you can use 23 format. This is for me crazy, but anyway, it works. But this was only for you. So once more, this was cheating. This was 23. But it's nice to know what works in the future. And now let me jump to concurrency. We have atomics since 11. So far, nothing new. But now you can do something very interesting with atomics. You can wait on atomics and notify. They have an extended interface. You can also do it on an atomic flag. And this is pretty nice. Why? How should I say this in a diplomatic way? Let me say directly, I hate condition variables. And this is a nice replacement.
But what is the weight doing on an atomic?
Sorry, what is?
What is an atomic weight doing? Is it spinning on?
No, there's no spinning. We don't have spinning. This would be terrible. Spinning would mean busy waiting, would meaning your room becomes very, very hot because one CPU goes to 100%. No, there's no spinning. But I have to say something. When you wait, this call blocks while atomic is equal to wall. So just keep this in mind. Now you understand my example. Here's a small synchronization example synchronizing threads. And I have a thread which produces data, and I have a thread which waits for data. So producer, consumer, sender, receiver workflow, right? And initially, I put atomic bool to false, which I would not have to do because the default value is false, but anyway, to make it more explicit. And then I wait on false, which means this call blocks, because this is false and this is false. And this is my notification. It stores true and then it notifies. And this means when this notification happens, this guy is awoken and it continues. Okay, jump back. I make it short. I only have 50 minutes left. Thanks. I make it short. The dumbest thing you can do in concurrency is to share. Or to speak in the words of Tony van Aert, I say it so often, forget what you learned in kindergarten. Don't share. And now we have a shared pointer, which is sharing by design. And therefore, we have an improvement of a shared pointer, stood atomic shared pointer, stood atomic weak putter. Not only now the control block is thread safe, but also the resource you care about. And this is what we have. Atomic shared pointer, atomic weak pointer. New specializations for smart pointers. Then we have semaphores. Semaphores is, say it in simplified word, a generalization of a mutex. You started with a value bigger than 0. Each time someone wants to have this thing, the count is decreased by 1. When the counter becomes 0, the requesting guy is blocked. This is a semaphore. And a mutex essentially has the values 0 and 1. But there's a big difference before I say nonsense and I'm recorded. With locks, you have to acquire and release it in the same thread, but not with semaphores. This is the big difference. But essentially, they're pretty similar. Okay, so what can you do? You can count down them. You can wait or try wait. Eventually, you get it. If not, you are blocked. You can wait for it. Sorry. Oh, some slide is missing. But essentially, this is what you can do. You can say count down. Let me say it differently. I show you an example. You can do an acquire release. Acquire counts down the counter by 1, releases, increases it by 1. So let me have a look. The same workflow such as before. Exactly the same. But now I use a counting semaphore. It can at most have the value 1, and I initialize it with 0, right? Here, this guy wants to acquire it, but he cannot get it because it's 0. First, the other guy has to release it. And this is an extremely simple thread synchronization thing. This guy releases it, gets a notification, now this guy can have it. And only to give you a short side remark, I was totally astonished when I made performance tests on Windows and on Linux, GC in particular. Semaphores are really, really fast. They're in the ballpark of atomics. 10 times faster than condition variables when you really want to measure them, on Linux at least. On Windows, it's not so, the difference is not so great. Okay. And then we have another synchronization, or let me say coordination mechanism, latches and barriers. A latch works kind of the other way around. You start a latch with a counter. When the counter is bigger than 0, you are blocked. And when the counter becomes 0, you can pass the barrier with the latch. So it works the other way around. Okay, so we have a latch. You can say count down. This automatically decrements the counter by 1. You can try wait, which will wait if the counter is, which returns you if the counter is 0 or not. You can just wait. This returns immediately if the counter is 0, if not, you are blocked. And you can say arrive and wait, which means you first call count down, and then you wait. And this mechanism, let me use this. Was this a barrier? Wait a second. If not, I have to go back. I use a latch. Here I have a latch. And what I do is, I initialize the count with 6. Why? Because I have 6 workers. Here are my workers. Herb, Scott, Bjarne, Andre, Andrew, and David. They have to perform this work package. It's a function object, a class for which I overloaded the call operator, something callable. What do they have to do? They have to do this stuff. First, the count is 6. Each time one thread appears here, it decreases the counter by 1, but all have to wait until the counter becomes 0. When the counter becomes 0, all is done, all preparation for the work is done, and they can go home. And you see it. Here, work done, work done, work done. Then it becomes 0, and all say, see you tomorrow. This is an extremely simple coordination mechanism. Latches and barriers. I make it a little bit shorter because I'm a little bit too slow. We have latches, which I explained here, and we have barriers. The main difference between barriers is, let me put it different. A latch you can only use once. A barrier can be used. So when you have more than one work package, and after each step you have to wait until all are done. Are you done with the preparation? Are you done with the work? Are you done with the second work package? Then use a barrier. This is the main difference. The interface is pretty similar, therefore I skip it here. But this is the main use case. Latch for one-time coordination, barrier for more than one-time coordination when you have a loop. When you want to have more sophisticated example, read my blog posts, but this is the general idea. Then we have cooperative interruption. And let me put it differently. Why is it a bad idea to kill a thread? Just go on.
Might hold a lock.
It may hold a lock. You don't know which state it's, if it's done with its work, or you have no idea. Now I know why you answered me. The rest is for me, so it depends on you how fat I end. This is terrible. Okay, cooperative interruption. And what we have in C++ 20 is cooperative interruption. Meaning you can ask very friendly a thread, please stop. And when the thread wants to follow your wish, it stops, if not, not. You can do it only once. And this mechanism is built into G thread, not thread, G thread, this extended thread, and also condition variable any, not the usual one, any. And this functionality is based on essentially 2 things. We have a so-called stop token and a stop source. The stop source sends the signal, and the stop token can react to the signal. And what you essentially do, you just copy the stop token in which place you want to react to the stop signal. So we have a stop token, which can ask, is it possible to stop? Or if someone asked me to stop. And then we have the stop source, which can create a stop token, can ask if stop possible, if a stop was requested, and this is the request stop. Sorry, this is the question, did anyone ask me to stop? I have 2 examples. The first one is extremely simple. The second one is a little bit more sophisticated, but honestly, this is my last example, so I'm good in time. Don't be. Only in order that you see nice output without interleaving and without buffering. I used, by the way, std_cr. Therefore, here's red. With cout, it would be black. Okay, what I have here is the following. I have 2. Never write lambdas which are longer than 2 lines. I have here lambdas which have more than 2 lines. You see, here I start a thread with the G thread. This thread has a counter. It counts up to 10. It sleeps for a fifth of a second, and it says just non-interruptible. And here the count is increased. Here I have almost the same code, but this time this G-thread gets a stop token. Stop tokens are extremely cheap to copy, just copy them. By design, they're cheap to copy. But here, you see what? I have a stop token. I can ask if someone wishes that I stop to run. And now here it's happening. Here's the main thread. I sleep for 1 second. Then I say, I interrupt both G threads, but only this one can react because this one does not have a stop token. You could also say a default create a stop token which no associated stop state. This was complicated. And now you see it. Non-interrupted, then they get the signal and only the non-interruptible continues. I first thought, oh, this is not so big feature, but then I recognized something. And this is a little bit more complicated. I first thought this is not so big feature, but essentially it's a really, really powerful feature. Any entity which runs can have a stop token, therefore you can send it a signal, please stop. Any. And here's a way more complicated example. I hope not too complicated. And it's not too complicated. Okay, have a look. Now I have a stop source from which I create a stop token. You see, looks a little bit like a promise future thing. From which I create a stop token. And now I copy this stop token in different running entities. In an old-fashioned stud thread, in a new G thread. I use it here in stud async. I use it here in a promise, you see. I use it here in, I can even use it by myself, here. And here's something special I so far not showed you. This function 2, which is executed in one of my threads, has a stop callback, meaning I can register a function which is called when I got a stop request. Once more, only once you can get a stop request. And I decided just to say stop requested. What should I do? I have no idea. And here you see what's happening. When I now say here, where is it? Here, request stop. All of them react in their way. So it's a pretty general mechanism to send signals. And I'm not sure why they baked it inside condition variable any or G-thread, but because I like more this explicit way to do it. For me, this is pretty explicit. You see exactly what's happening. Yeah? Is the stop token automatically atomic? All this stuff is atomic by design. If not, this would not be usable because you use it typically in a concurrent environment.
I don't have to protect it. I could assume it's safe.
Yeah. Okay, this was it almost. There's only one feature I mentioned, and you ignored it. You ignored it. Here's also a C++20 feature. You have to be careful.
I was going to say about it.
No, it's too late. We have also synchronized output streams in C++20. Meaning, before 20, you only have to guarantee that the character is written atomically. Now you have to guarantee that all the stuff is written atomically. Essentially, how it works is the following. It's extremely easy. It's extremely easy. Oh, 40 seconds left. It's extremely easy. Here I create a temporary. Here. How long does this temporary live? Until the next sequence point. Here this temporary goes out of scope. It calls its destructor, and now std out is flushed. And therefore, the sentence is written in an atomic step. And what is the key idea of this pattern? I should say it differently. In my class 2 days ago, they said it. This is RAII, another application of RAII. You register an action which is performed when this local thing goes out of scope. Oh, perfect. Minus 8 seconds left for questions. No, forget about it. When you want to know more, I have written a lot about it. Of course, the book, I should mention, and also my mentoring program. But anyway, my blog posts. Now I'm done.